Today, we have an interesting question on logarithm. Given that 8 raised to the power of log x minus 2 to the power of log x equals to 5 factorial, we are asked to find the value of x. Okay, solution. Please kindly pay attention, okay? Don't forget that 5 factorial can be written as 5 times 4 times 3 times 2 times 1. And this will give me 120. Okay, so we have done this. Now, an 8 can be written as 2 raised to the power of 3, right? So now let us replace 8 as 2 to the power of 3 here and 5 factorial as 120. So I'm going to have, instead of 8, I'm going to have 2 raised to the power of 3 multiplied by log x minus 2 raised to the power of log x equals to 120. Do you understand? Okay, now let log x, please pay attention, let log x equals to a letter. So let log x equals to a. So for this, I'm going to have 2 raised to the power of 3 multiplied by a, because now I've already set log x as a. So multiply by a minus 2 raised to the power of a equals to 120. Are you following? Okay. According to laws of logarithm, 2 raised to the power of b multiplied by c, okay, 2 raised to the power of bc can be written as 2 raised to the power of b raised to the power of c. So for this, I'm going to have 2 raised to the power of a raised to the power of 3 minus 2 raised to the power of a equals to 120. I have not done anything. All I did was that I just used these properties. You understand? I used these properties of indices that if you have an exponent that is multiplying each other, you can raise that exponent to the power of another exponent. Are you getting what I'm trying to say? You can raise that exponent to the power of the second exponent. So the same thing I did here. 2 raised to the power of 3 times a can be written as 2 raised to the power of a raised to the power of 3. Do you understand? Minus 2 raised to the power of a equals to 120. Okay? Now, the next step is that let 2 raised to the power of a equals to p. Do you understand? We set it equals to another letter. So for this, I'm going to have p raised to the power of 3. P raised to the power of 3 minus 2 raised to the power of a. I'm going to have minus p equals to 120. Okay, now looking at this question, what values will p be to make me have 120 at the right hand side? I don't know. Well, you can check for 5. 5 raised to the power of 3 is 125. So for this, I'm going to have 125 minus 5. This will give me 120. Do you know? But there is a way we can solve this. We can prove this without guessing. Do you understand? And that's what I want to do now. So please kindly pay attention. Now, I can rewrite this 120. We can rewrite it as 125 minus 5. Do you know? 120 can be written as 125 minus 5. Okay? Now bring it. P raised to the power of 3 minus p. P raised to the power of 3 minus p equals to 25 can be written as 5 raised to the power of 3. And I'm going to have minus 5. Do you understand? Okay? For this, I'm going to have p raised to the power of 3 minus 5 raised to the power of 3 minus p plus 5 equals to 0. Do you understand? Okay? Do you know the reason why I did the reason why I use this approach is because I want to use difference of 2 cube. Do you understand? I want to use difference of 2 cube. For example, if you have a raised to the power of 3 minus b raised to the power of 3, this can be written as a minus b multiplied by a squared minus ab plus ab plus b squared. Do you understand? I want to use these properties. That is why I approach this question this way. Do you understand? Okay. You know, by guessing, we can know that p is 5. And our solution, please listen to me carefully. We are only looking for the real solution. We are looking for the real solution. Okay. So let us proceed. For this, I'm going to have, now let us use these properties here. I'm going to have p minus 5 multiplied by p squared plus 5p plus, now b squared. Please pay attention. B squared, the b now will be what? 5. Minus 5 raised to the power 5. 5 raised to the power 5 is what? 25. So I'm going to have plus 25. Okay? Minus p. Okay. Minus multiplied by p minus 5. This will be equals to 0. Minus times p minus p. Negative times negative 5. I'm going to have what? Plus 5. So from this point, factorize p minus 5. I'm going to have p minus 5 p squared plus 5p plus 25, okay, minus 1. This will be equals to 0. Do you know p minus 5 times this, I'm going to have this. Are you getting it? And p minus 5 times minus 1, I'm going to have minus p minus 5. Do you understand? So having gotten to this point, we can set p minus 5 equals to 0. So I'm going to have p minus 5 equals to 0. Or p squared plus 5p plus 25 minus 1 equals to 0. Do you understand? Okay, now let us deal with this first. I'm going to have p equals to 5. Okay, now having gotten the value of p as 5, now listen to me carefully. This quadratic equation, p squared plus 5p plus 24 equals to 0. If you take the discriminant of this quadratic equation will be less than 0. Do you know? The discriminant, that is b squared minus 4ac, will be less than 0. And the simple reason is because we cannot, so we don't need to solve this quadratic equation. Do you know the reason? The reason is simply because the discriminant is less than 0. And if the discriminant is less than 0, this quadratic equation doesn't have any real root. You understand? There is no real root because the discriminant, b squared minus 4ac, is less than 0. So the only real solution that we have is p equals to 5. Do you understand? Okay, now let us go back to the question. The goal is to find the value of x, not the value of p. Do you know? So, having gotten the value of p as 5, don't forget that 2 raised to the power of a equals to p. Do you know? Now, I'm going to have 2 raised to the power of a equals to 5, right? Now, I'm going to take the logarithm of both sides. And the base of that logarithm is 2. Do you know the reason? The simple reason is because if according to this law, log x base x raised to the power of maybe t will give me what? T. Because log x base x is what? 1. And logarithm of log of a power is the product of the power and the log. Do you know? So I'm going to have t times 1, which is what? T. The same thing I'm going to do here. Log base 2 raised to the power of a equals to 5. Oh, sorry. Equals to log 5 base 2. Okay? So here I'm going to have a will be equals to log 5 base 2. Now, having gotten the value of a as log 5 base 2, don't forget that we have already said let log x equals to a. Hello? Log x equals to a. So for this, I'm going to have, pay attention, log x will be equals to log 5 base 2, because now a is log 5 base 2, and we have already said that let log x equals to a. So to get the value of x, I'm going to use these properties of logarithm. Log y base 10 or log y base x equals to a in logarithmic form. I can write this in index form as y equals to x raised to the power of a. The same law I'm going to apply here, okay? Now, x, do you know that the base of this logarithm is what? Is 10. So I'm going to have x will be equals to 10 raised to the power of log 5 base 2. Do you understand? If you didn't understand, listen to the explanation again. What I applied there is the laws of logarithm. Do you understand? So I'm going to have x equals to 209.859. Okay, don't forget to subscribe to the channel, like the video, share the video. Also, drop your review in the comment section, okay? So that will be all for this class. See you in the next class.